is Kevamshi from AC B section. So today I want to discuss about the topic rotational mechanical system in the subject control systems. So coming to the topic, what is mechanical system? In dynamics, the mechanical system is a system which possesses some motion as a result of compressive force. So every body can have some movement by applying some external force. By that we can define some force displacement like dash point, etc. So coming to the basic elements of the mechanical system, we have mass, spring and dash point. While calculating the sub parameters, we taken these three things as a parameter, like so where M is a mass in kg and K is the stiffness of the spring in Newton per meter, also B equal viscous caused by dash point, and friction coefficient Newton per second per meter, and X is a displacement and F is a force applied. So by applying the force on a object of body mass M, and you can see the spring and dash point at other side, which makes displacement by body due to the force. So types of mechanical system, it is divided into two mechanical system, like translation mechanical system and rotational mechanical system. So in this we will see about the rotational mechanical system. So this mechanical system moves about an axis known as a rotational mechanical system axis. So unlike the translational mechanical system, in translation mechanical system it move and forth, but here rotational mechanical system it moves at the point of its axis, like moving clockwise or anti-clockwise at same space. So we can use some symbols in this, known as angular velocity. Angular velocity, it is the rate of velocity at which an object is rotating around a center in a given time period. So it can use it to denote it by dO by dt, and units are radian per second. And applied torque is a measure of force that can cause an object to rotate about an axis, and similarly unit is Newton per meter. So coming to the rotational friction coefficient, the friction that opposes the rotation with a constant torque at any velocity, like symbol is B and unit is Newton per second per radian. And the another is stiffness of a spring. So it is also a friction spring constant. Measure the stiffness of a spring is a measure of resistance offered by elastic body to deformation, denoted by K and Newton meter per radian. So let's get into the definition, explanation and example of the overview of the rotational mechanical system. Coming to the definition of a rotational mechanical system. Rotational mechanical system move about a fixed axis, and the system mainly consists of three basic elements. The basic elements are mass, dashboard and torsional spring. So here you can see the example body which experience some rotational body, when we applied a rotational torque, it moves around it, moving around the axis, like moving clockwise or anti-clockwise. And we can consider three objects, like a dash band and spring and torsional spring, so which affects the resultant torque about this free body. So here K define the stiffness of a spring, and B is the torsional dash point, and M is the mass of body, and T is the torque applied on the body, where theta 2 and theta 1 denotes the angular displacement of a body. So coming to the torque calculation of a moment of inertia of a mesh element. In rotational mechanical system, moment of inertia stores kinetic energy. If a torque is applied on our body having moment of inertia J, then it's opposed by opposing torque due to a moment of inertia. So if we apply a torque on a laser body, an opposite force is generated due to a moment of inertia. So this is proportional to the angular acceleration of body. So assume elasticity and friction table negligible. Like for the and calculation of moment of inertia of a mass body. So you can see the free diagram of a rotational mechanical system which has J as mass and A is the angular velocity and T is the torque applied. So it can denote as Tj equal J into jd square by dt2, and where T is the applied torque, T is the opposing torque due to moment of inertia, J is a moment of inertia, A is the angular acceleration, and 9 is the angular displacement. So torque calculated dashband. If a torque is applied on dashband, then it is opposite by an opposing torque due to a rotational friction of the dashband. This opposing torque is proportional to the angular velocity of a body, and assume the moment of inertia and velocity are negligible. So calculating the torque, calculating the torque in dashband, let dB equal W. When one end of the dashband is fixed, you can get T equal TB equal B, and when both end is free, T equal TB equal D by dt of 90, like at the points. So where T is the opposing torque due to the rotational friction of a dashband, and B is the rotational friction coefficient, W is the angular velocity, and 9 is the angular displacement. So torque calculation in torsional friction. In rotational mechanical system, torsional spring stores potential energy. If a torque is applied on the torsional spring K, then it is opposed by an opposing torque due to electrification of torsional spring. This opposing torque is proportional to the angular displacement of the torsional spring, and assume that the moment of inertia and frictional are negligible. So torque calculation in torsional spring. So when one end is free, we get T equal to Tk equal K naught. When both ends are free, T equal K naught by 1 minus 2. So these are the two ends of spring ends. So where T is the applied torque, T is the opposing torque due to elasticity of torsional spring, K is the torsional spring constant, and A is the angular displacement. So I think we got enough information regarding the rotation. Let's see an overview. So you can find the rotational mechanism body where spring is attached to a rigid body, and it is one end it is attached to the free body, and another end is attached to the dashboard, and this end is attached to the another body. So torque is applied at one side of the body, and other opposing torque is generated due to a elasticity due to a moment of inertia. So these are generated by dashband forces Br1 and spring constant is Kn, and T2 is the angular moment. So torque reaction in moment of inertia of mass in, so this can be calculated by using T equal to Tj equal Jd to dt square, and torque calculated in dashband. If the torque is applied on dashband, then it is opposed by opposing your torque due to the rotational friction of dashband. So every applied torque, there is opposite equivalent, there is opposite force applied at the end of another. So torque calculated in dashband. When one end of the dashband is fixed, T equal TB equal BD. When both ends are end is 3. So where T is the opposing torque due to a rotational friction of dashband. B is the rotational friction coefficient, and W is the angular velocity. And so we can similarly calculate the torsional spring calculation in torsional spring. So like finally we get T equal Tk is a spring constant torque. So thank you. Have a nice day.